Okay, guys, good morning, good morning. This is 8 to 17. This is what I would think if I were to come out here and looking at this, and this is the way I approach it and do this one. See all these things? I know these are my y-intercepts, the ones that are just the numbers by themselves. Okay? Let me see. And that's a parabola opening up, that's a parabola opening up, that's a line with a negative slope. I think the answer is A already. Then I have a y-intercept of 7. Okay? In that sense, if you know x is 0 because you're on the y-intercept, then this goes 0, 0, then that's 7. 0, 7, 0, 7. So this is true. That one's right. Let's just prove it now. Okay, ready? They don't all have vertex. They don't have two solutions. They don't have an axis symmetry. You know what? This is a lie. This one, they all have axis symmetry. This is another line, but we haven't covered that one, so it's out of our pay grade. / answers A. Let me just prove it to you. So this way you should do it, I guess. Just graph it. Graph it. Graph it. First one will be the first one, x squared plus 8x plus 7. And I'll press tab. Oh, my bad. And then I'll type in the next one, 3x squared plus 7. Whoa, where's that one? And then tab. You know what, let me go to menu, zoom out. Okay, there's the other one up there. So I'm going to come back here, go to tab, and I'll type in the third one. Negative 4x plus 7. Okay, so the axis of symmetry, where's my writing tools? My bad. So they all have a y-intercept of 7. They all cross that point right there. So I'm going to say yes. They all have a vertex of 0. I'm telling you this one's a line, so it doesn't have a vertex. I don't even care what it is. They all have two solutions? No. This one has one solution, two solutions. That one over here, the red one, no solutions, one solution. I still like that one the best, okay? All functions have an axis symmetry. They do. This one's axis symmetry is here. This is axis symmetry here. And as long as you choose one here like this that's perpendicular to it, you can say this is axis symmetry of this one. But that's not true, but true. But we're going to say that's not true for us. Okay? Hold on real quick. Okay, if fx and gx are parallel linear functions, find gx if fx is equal to 3x plus 2, and gx is translated 4 units down. Okay, so for them to be parallel, they have to have the same slope. For them to have the same slope, we need to find out where our slope is. Y equals mx plus b. M is my slope, so my same slope would be 3. Out, out, check, check. Okay. Now, this number here is your y-intercept. That's your slope. This is your y-intercept. And when it comes to your y-intercept right there, that's going to be where your line crosses the y-axis. Now, if it's crossing it there at a positive 2, so I'm going to just draw it real quick. Positive 2, that's this one. And this one's 4 units down, so we'd go down 1, 2, 3, 4. We'd be crossing this as my new y-intercept. Okay, pretty easy. And if you don't like that and you don't want to think, that's actually not thinking. That's like really easy. Just graph it. Okay, we'll go with 3x plus 2. Now, I know those two don't have the same slope. I know the other one does have that slope. So I'm going to go out here and look at the one that is 4 units down. Okay? I'll go with 3x plus 6. That's above it, so not even close. And press tab, go up, and delete this. Oh, my bad. Minus 2. And look at that. 1, 2, 3. Oh, wait. Sorry. 1, 2, 3, 4 units down. D is my correct answer. which expression is a simplified form of this one? So this one basically wants you to just distribute and do the work, right? Or clean it up, or rewrite it, okay? So I'm going to distribute here and here. The first distribution would give me a negative 2x squared. The second one would give me a plus 4. This one here gives me a negative x squared. The next one here gives me minus 4. I'm going to go ahead and put stuff together. Stuff that goes together goes together. This and this gives me a negative 3x squared. This cancels with that, so we're just left with that. Wait. Okay, so let's look at this madness. Okay, so I had told you about this one. You know, I hadn't seen this. I skipped the first 6 weeks. I just don't like the way they teach it to you. I don't like the way they do this, right? So you got to see this when they say, let me see the question. First terms, okay? Nth term, like the position, okay? Position, nth. So this is what I want you to look at it like this. This is going to be when x is 1, you have y to be 7/8. When x is 2, they want y to be 3/8, or 13/8. When x is 3, they want y to be 19/8. Now, look at these. They're all linear. All of them are linear. The reason I know they're all linear because there's no squared here, no squared here, no squared there, no squared there. So all linear. So what I want to do, I want to make my life easier. Way easier. And I'm thinking this one. Right here. I'm going to go to List and Spreadsheet. List and Spreadsheet, menu 413. That's it. Really easy. Really simple. Okay, 7/8, 13/8. Well, if you think about that, how did it go from here to here? It increased how much? 6/8, which is what, 3/4? Is it that one? What do you think? We'll just go find out, ready? So I'm going to turn it on, menu, no, list and spreadsheets. I'm going to go, remember, the first term is going to be fraction control division, guys, 7/8. Here is 2. Ooh, my bad. 2, and then that one's going to be control 13/8. Come back to the A column and go to menu 413 because it's linear. B, control B, control, and there it is. Here. So, so we're going to have y is equal to mx plus b, right? That's the form we wanted in. M to be 3/4. See that? You see that right there? It's 3/4. X plus my b, 1.125 is 1/8. That's my answer. Okay? Hopefully that made sense. So the trick is to see this once you see position, term, okay? See that, honestly, as x equals to 1, we have y to be 7/8. X equals to 2, y to be 13/8. And that's it. It's not hard, guys. Really easy. Let me see what. Number 5. Shade above. So, really, for it to be above, you want y is greater than, okay? Shade above the line. It doesn't say dotted line, solid line. Okay. So we're going to look for that idea, right? This means y is greater than. So for this, you need to solve for y. All right, you need to solve for y. So it's subtract 5x. So I'd have a negative 3y is less than a negative 5x plus 2. I really don't care about this, guys. I really don't. I just want to see what happens with this right here. Okay? I'm going to go ahead and divide by negative 3. divide all this by negative 3. I really don't care. Again, I really don't. I'm really worried about looking for this. Okay? Now, in this situation, this cancels out. But since I divided by negative, guys, it gives me y is greater than. That's my answer. Cool. This is obviously wrong. If I switch this around, if you think about this, this is like not much to do here, right? But if I switch this around, if you don't mind, I'd have y plus 2. You see how it's eating the x? I'm going to put it like that, eating the x. To get the y by itself, I'd minus 2, and I'd have y is less than. Wrong. This is already wrong. Here, if you think about it, minus 3x, and then I would divide by a positive 2, slash this thing would not change. Correct answer. What are the solutions to the quadratic equation in this one? Okay. So I've told you in this one, guys, this is a quadratic. Solutions are those words. They're very important. It's going to be the root, the 0. In my opinion, the most important one, the x-intercept. Come on, don't slow down, computer. The x-intercept. Now, regarding the x-intercept, guys, graph this thing. But you cannot graph it like that. You have to set it where it's equal to 0. So for this one here, we're going to minus 5, and we are going to graph this now. We are going to graph, ready? X squared plus 2x minus 5 is equal to 0. That's it. We're going to graph that one. These are all numbers. Okay. This one here, I showed you guys. This is really saying two things in one. It's really saying 2 plus the square root of 16 over 2. And it's saying 2 minus the square root of 16 over 2. I don't know. That's a weird answer. This is not a good answer. That's not a good answer. The reason I'm saying it's not a good answer because that's a 16 square root 4. This is really a 4. I can see that one staying there, and I can see that one there. These two are weird. It's just trying to play with your brain. Okay. So regarding this part right here, this one really is going to be 4, right? Plus 2. 6 divided by 2. Also known as 3. This one here is 4. 2 minus 4, negative 2 divided by 2, negative 1. Look how I'm doing this. I'm not putting them in parentheses. They are not solutions. They're not like a coordinate. They're not a coordinate. They're individually items for the answer. That's a number 3. That's one of the answers, and that is another answer. This says it's a point. We're not saying that's a point. We're saying the two answers are 3 and negative 1. Okay, so you got to understand that's part of algebra. That's how it's written, how to communicate, how to talk about it. Where am I at? So I'm going to graph this. You see this right here? I'm going to graph that. X squared plus 2x minus 5. So I'm going to go with x squared plus 2x minus 5. Graph that. So they're my answers. You know what? I can't be too sure. Let me do two things. I'm going to do menu. I'm going to get the 0. What is there from this left side? It's a negative 3.45. And then we do the menu, analyze graph, get the 0, and I get the other side, 1.45. Okay? So I tell you that one's out. Right? Not cool. So I know it's not A. I'm going to try this one here. So it's going to be a negative 2 plus a square root of 24 over 2. And I'm also going to try a negative 2 minus the square root of 24 over 2. Now this is kind of crazy to work on your own to get a decimal. So that's why we gave you a calculator. So let's go and do this stuff right here. We'll do it on a calculator. Remember, negative 0.45 and 1.45. So I'm going to turn it on to cancel. Let me go back to the document. Escape. Go back to my current one right here. Time out, guys, real quick. Okay, guys, so this is what I want to do. You see, I want to get those numbers. I want to add it on a page. So I'm going to go to Control, add a page, and I'm going to add a calculator. And I go back and forth to check the numbers I want, you see. So for this one right here, I'm going to type it in there. I want to go right here. I want to make a whole fraction. Ooh, my bad. I'm going to get whole fraction right here. I'm going to type in a -2, and I'm going to do one of them. I'll go with plus the square root, you see it right there, 24 over 2, enter, 1.44. And the numbers I want are in, hold on, reference case. Okay, so I really want that, what is it again, 1.44. You think, you know what, it might be that one. Oh, wait, is it positive or negative? You know, I think it might be that one. So let's try the other one now, right? Going to add a fraction again, and go with a -2. Now we're going to go with minus the square root of 2. Square root, my bad, of 24 over 2. Ooh, I think that's the answer. Yeah, you know what? I think that's the answer. I'm leaning towards that one. Let me just disprove these over here. Okay? I'm going to type in 2 plus. Okay, let me show you that trick, I guess. If I highlight the one above it, here, and I just delete that negative. That's exactly what I want, right? Enter. 3.44. Okay, so that one's already at 3.44. We want a negative 3.44. So that one's out. This one over here. Okay, so I'm going to highlight the, I'm going to press up. Did I do the other ones or no? No, I didn't. Okay, so I'm going to go here to this one, highlight that one, change that to a plus, change that to a 16, and that gives me a 1. So no, not even close. The best answer, B. Cool? What is the sum of the x and y coordinates of the solution to the system? Oh, this is a good question. Basically, solve it. Whatever you get as your coordinates, add them up. Really easy. So this one, you better know how to do this one already. 2 equations, 2 lines. So I'd come here. Actually, I can do it here. It's already in the calculator. I'll go to menu, 3, 2. I'm going to type those in there. 18x minus 6y equals 2. And I'll come right here. I'll go with 9x plus 3y equals 5. Ooh. Basically 1/3 plus 2/3. You better know that. C. Okay, so which data has a rate of change? So make sure you know rate of change is your slope. Slope here is 1.6, which is like 0.166. I think it goes on forever like that. I think it's that. Let me double check. Come on here and go division 1 over 6. And look at this trick, decimal. And see, it goes on forever. So I'm going to do this. I'm going to turn it on, go to a new thing, list in spreadsheets. And I'm just going to use the first two, guys. I'm going to go -3, 20. Make sure you go that one, goes to that one. 1 goes to 4. And I go to menu, 4, 1, 3. I go to B. Okay, so this one, -3, 20, and 1, -4. No, not going to work. So now what I'm going to do is just change the numbers case. I'm going to go to 0, and the kit automatically changes it. 0, 3. Oh, my bad. 0, 2, and 3. 0, 2, and then 3 and 2.5. Ooh, that's my answer right there. B's my answer. Okay. And that's it. Going once, going twice. Okay, next one over here. Which point is a solution to the inequality? So in this situation right here, we need to graph this, right? Let me see. I want to rewrite it, if you don't mind. I'm going to put this on this left side. I'm going to have it at 2y, and I'm going to put it this side. You see how it's eating the 2y? I'm going to have it eating the 2y over here. 3x minus 5 divided by 2, divided by 2, divided by 2. I'm going to go with y is greater than 3 halves x minus 5 halves. Now I'm going to come right here and go, okay, this is 2.5, right? 1, 2.5. My bad, it's negative. That's that. And then my slope of 3 halves, so I'm going to go up 1. Okay, from here to here is 1, and 2, and 3. Then 2 to the right. 1, 2. So I'm right here in the middle. So this line goes like that. This one goes here. My line goes like this now. Oh, and it's dotted. Man, there's a minor mistakes this morning. And a lot of them. Okay, my boundary is like this. So there's a shade above. So I'm going to shade on this side. Saying which of these is a solution. So that's going to be 0, 0. Check. I like that one. 1, negative 1. So this is below, out. 2, negative 3. So right here, out. 5, up 4. I want to say it's 1, 2, 3, 4, 5. And 1, 2, 3, 4. Probably below it. Probably just below it. Answer. This one here, given the quadratic function below, a solution of the graph lies between what two values? A solution. That means remember your root, here's 0, and then we'll go with your most important one, in my opinion, or my most important one, x-intercept. So between, this is one right here, this one right here. So between -2 and -1, between -2 and -1. No. Between 3 and 4. Between 3. A solution. I'm lost here. Hold on. Maybe I read it wrong. Given the quadratic function below, a solution of the graph lies between what two values? -1 and -2. I don't see -1, -2. Between 3 and 4. I'll go with A, B, C, D, E. None of the above. I'm thinking that I don't see what's going on here. I'm thinking maybe these will be negatives. Yeah, we're gonna give it like that.